Good afternoon, ladies and gentlemen. We are Team Propulsion, and today we will be presenting on our UAV project on the future of wildfire fights. This is an overview of our presentation. We will first be going through the problem, and then the mission and UAV design, and finally the evaluation. First, the problem. Our mission is to deliver early resolution to forest and peatland fires in Australia and Indonesia respectively. Such fires not only have social costs but also economic costs to the affected countries. For example, the 2015 Indonesian peatland fires caused at least 19 deaths and 500,000 cases of respiratory tract infections and approximately $49 billion worth of economic costs. In Australia, the 2013 New South Wales fires destroyed at least 248 dwellings and buildings, with more than 118,000 hectares of bushland burnt. Given that 1 hectare is approximately the size of a rugby field, it is easy to visualize how large the extent of the damage was. Next, evaluating the effectiveness of current satellites used to detect forest fires. The Sentinel hotspot system used in Australia only moves past Australia 2 times a day. Thus, the time lapse between when the fires develop and when they are detected will hinder early resolution of them, making this essential as a problem to solve. These reasons therefore highlight the importance of our mission, the early resolution of peatland and forest fires.
Now that we have covered the importance of the problem to us, now let's move on to mission design. The mission design consists of 3 phases: detection, resolution, and sustainability, which will be carried out by 4 drones. Scout will be responsible for detection, while Resolve 1 and Resolve 2 will be responsible for resolution, and Whistleblower will be responsible for sustainability. So let's imagine this situation. If a heat region develops, the role of Scout is to spot this heat region using visual and infrared cameras and to transmit the geographical coordinates of this region via GPS to the other drones. Differentiating factors for Scout include 24/7 operation readiness, allowing operator to deploy it anytime, anywhere, navigational capability, unlike satellites which have to move in fixed orbits, and precision imaging because it is closer to the ground.
For payload operations, firstly, the wings of the Scout drone are covered with solar panel, which can provide power for long-endurance missions, prolonging the time over target for the drone to navigate a large area of forest. Fuel tank will also be equipped to provide fuel for night flying. Secondly, the drone will use infrared and visible light sensors to provide real-time imaging and collect information on the temperatures of the surrounding. Thirdly, Doppler radar is used to sense the airflow in the area and provide real-time prediction on the future escalation or movement of the fire. After receiving the data, the drone will transmit the data to the satellites or other drones through antenna. Since the forest fire is likely to take place in remote areas and there might be no ground-based control station nearby, the drone could serve as a relay for effective communication.
In order to adapt to the typical high-altitude, low-speed flight the mission requires, the Scout adopts a small aspect ratio wing to reduce the drag for the low-speed flight. In order to minimize the weight, V-shaped tail is used, rather than the traditional set of vertical and horizontal stabilizers. Despite that, this would make the maneuverability slightly compromised, which is not really needed for its mission. The under-cambered aerofoil could also reduce the drag while providing higher lift under the low speed condition. Additionally, the low wing configuration allows the use of lighter landing gears that further reduce the weight of this drone. A wind tunnel simulation is done for this drone under its typical flying conditions. 40 meters per second with 10 degrees angle of attacks. Smooth flow with little turbulence can be observed that further proves the low drag feature of this drone.
Next, Resolve 1 will move in and deliver the Elite fireballs to carry out the macro strike to extinguish most of the fires. It will use a visual camera to identify the heat region. Differentiating factors for Resolve 1 include full access and mobility. Unlike ground vehicles that have to navigate through complex terrain, it maximizes the target zone because the Elite fireballs have a radius of 8 to 10 meters, and it reduces fatality rates by decreasing the exposure that firefighters face when they are fighting fires.
For payload operations, when the drone detects a fire, it will release the fire extinguishing balls, which will be directed to the target position by laser guidance. The balls will self-activate within 3 seconds when they come into contact with the fire and effectively disperse extinguishing chemicals while giving out an alarming sound. In addition, the balls are approximately 1.5 kg light and are relatively safe for usage since the drone need not get close to the fire.
Unlike the Scout, this drone is designed for low altitude and medium speed flight. Thus, a T-shaped tail is used to increase maneuverability, and the downward winglet at wingtips is to reduce the drag. The high wing configuration allows the takeoff at poorly conditioned remote airfields. Similarly, like the Scout, it has an under-cambered airfoil shape, and a wind tunnel simulation is performed to demonstrate the low drag encountered by this drone under its typical flying condition.
After the macro strike, there will be regions where the fires aren't extinguished. Hence, Resolve 2 mission is to extinguish these fires using an acoustic extinguisher and carry out what is known as a precision strike. It uses a thermal camera for greater precision and accuracy. Differentiating factors for Resolve 2 include reaching cramped spaces because it is small and no existing vehicles can do so, and it has a precision strike which, unlike any other vehicles now, they all carry out strikes that will leave fires behind, and this would increase the usage of resources to extinguish them. And this brings on to the next factor, which is reducing resource wastage by reducing the number of return trips that the fire extinguisher vehicles have to make.
For payload operations, similar to the scouting drone, the infrared and visible light sensors will be used, and the geographical locations will be sent to the control stations or satellites via the antenna. Smoke sensor and gas detectors are also installed on the drone to detect small flames. In addition, the drone will be equipped with acoustic fire extinguisher, which uses waves produced by a low-frequency sound to put out fire. It is especially suitable for small controlled fires and offers a relatively non-destructive method of fire control.
The efficiency is achieved through the propeller blade design. It has a medium diameter so as to achieve the balance between lift and drag. Also, the propeller allows the auto adjustment on the blade angles so as to create equal angle of attacks across the disc to prevent the stall of the blades. Also, the balance of the drone would be a challenge for the quad prop. To counter this issue, the stabilization can be achieved through adjusting the power output of each propeller to keep the drone in the air.
Lastly, we will deploy whistleblower to watch out for any re-emergence of fires, and it will do so via a thermal camera, which also gives it greater accuracy, and it will be solar powered for endurance. What differentiates whistleblower from its job is that it defends against initiating factors, and currently there are no measures to do so, and this can waste previous efforts in extinguishing the fire. Hence, this leads to cost minimization, ensuring that previous fire extinguisher efforts are effective, and it also decreases the search area, meaning that the Scout does not have to search such a big area as before, and this is good for the overall mission cost.
The drone uses infrared or ultraviolet sensor to detect and respond to the presence of flame. These flame sensors are sensitive to both infrared and ultraviolet wavelengths, and they can detect flame by comparing the threshold signal of both ranges. This helps reduce false alarms. The drone is also equipped with 3D laser terrain sensor, which can collect information regarding forest structure and terrain characterization. This will create high-resolution maps for the drones to monitor the forest. In addition, air quality sensor will also be used to aid in the detection of fire.
For the whistleblower, the design will be largely similar to the ones of Resolve 2. However, as it is powered by solar power that could encounter the problem of power shortage at night, it is equipped with ultrasonic distance sensor at its bottom so as to facilitate the autonomous landing for battery recharging. Moving on to product life cycle management. In order to facilitate maintenance, most structures of the drone fleets are made of composite materials which are designed to withstand high temperature and prevent metal fatigue. However, for the rest of structures such as holders, pylons, and etc., titanium is used. Although this could increase the cost, it could bring about advantages such as low weight and good strength. In order to prevent metal fatigue over its parts, the traditional maintenance techniques are recommended that ultrasonic or X-ray detection can be used for preventing metal fatigue from occurring. Since the drones are exposed to poor atmospheric conditions due to the pollutants from the fire, they can suffer from the corrosion of the surface. Thus, corrosion-resistant coating will be used to protect metal components against degradation due to the moisture or exposure to a variety of pollutants. Also, for Scout 2, as it requires to perform close-up detection, preventive measures can be applied, such as the heat-insulating coating before flight to prevent overheat of its internal parts. Due to the rapid science and technology advancements, nowadays it is important to make drone compatible with future sensors which could provide a significantly better capability in fire detection and extinguishing. Therefore, the concept of modular design is applied when the drones are designed. This feature consists of extra space left in the drone, universal ports for sensors such as PCIe, SATA, or USB that makes the drone fleet easily upgradable. Although this could increase cost in the short term, however, more cost saving can be achieved through upgrading them consistently in their approximate 15 years lifespan rather than replacing them with newer models.